We are team Greenverse presenting our sustainable packaging innovation. Please go ahead. So this is our team. He is Sumit, he is Shubham, and I am Ritesh from IIT Bombay. And before I move ahead, I will like to share some stats first. So as you can see that between 1970 to 2019, estimated 30 million metric tons of plastic had accumulated in the ocean, and humans currently produce more than 400 million metric tons of plastic waste per year. Without changes to current policies, if we will be going like this, then it is projected that by 2060 this waste get to by number it will get tripled. And the interesting part is that 40% of this plastic waste is from packaging. Go ahead. Yes. So what is our problem statement? So as we can see that there is a lot of contribution to this packaging waste that is impacting our environment in negative way, and the methods that we use to create such packaging are very resource intensive. These consume a lot of energies. So we need a sustainable and scalable alternative for such things. Okay.
So our proposed solution is mushroom-based packaging. Mycelium, the root-like structure of fungi, we can create biodegradable packaging that is durable, lightweight, and shock-resistant. Mycelium binds agricultural waste such as corn stalks or husk to form a sustainable material ideal for protecting delicate electronics and other stuff. Our packaging is entirely biodegradable and breaks down naturally within 30 to 60 days. This ensures minimal environmental impact. It serves as an eco-friendly replacement for plastics and styrofoam. It serves the product process requirements, minimal energy, reducing carbon footprint. This not only makes it sustainable but also effective for widespread adoption. Importance: this innovation addresses landfill overflow and marine pollution while meeting increasing consumer demands for sustainable products. Further, companies face increasing regulatory pressure to adopt greener practices, making our solution not only environmentally but also economically and socially relevant.
So, let me walk you through the methodology, how we are going to design our product. Firstly, we are using agriculture waste like corn husk and husk of various like rice facade. So, and in that we are adding fire resistant additives as well as water replicant additives. The fire resistant additives like aluminum hydroxide and magnesium hydroxide, and water replicants are boron compounds and fluoropolymers. So followed by that, we are designing customizable molds in which we are growing our mushrooms for with perfect dimensionality, and finally we are curing and finishing for making it more durable. So what really sets apart our product? Firstly, it is naturally grown. There is nothing synthetic process is used. Followed by it is customizable, as you know, from which we can make our mushroom with perfect dimensions. And nextly, it has dual benefits because we are recycling our agriculture waste and reducing plastic waste. Finally, we are reducing carbon from the husk ash. That as we know that husk ash also carbon. So we have reducing it by less than 90%, and we have 3 samples which we have reduced in the lab and Professor Karthik from Intelligence Department. So have a look over here. So first process, we have calcinated it twice for a better carbon reduction, and we have leached it with HCl.
Yes, Professor Karthik from Idearium.
And we are moving ahead in making the prototype of this package. So what are these impacts?
So yes, majorly it will be serving the it will be making these three feel very impactful. First thing, toward the environment, it will reduce the plastic waste. That is because of packaging. As I said, 40% of this plastic waste is because of packaging. Another thing is it is cost effective, so it will be also very economical to everyone. And another thing is social. As we know that now people are being concerned about such images like when such some companies are environment friendly like the body shop. Now people are getting more attracted toward it. So it is also good for the corporates also. Now there will be some challenges for which we are having some approach to solve this. So one of them is that how will we ensure the consistency among the product. So for this we will need to develop some quality controls system so that we can be consistent in this. Another thing is that the problem will be with scaling. That as we know that packaging is very important in almost every product. So to meet the industrial demand, we need some scalable solution. So we will collaborate with the local agricultural suppliers so that we can get the supply of raw materials consistently. Another problem is that since it can get affected by the moisture, but if we will use some additives which can be hydrophobic, then definitely we can solve this problem. Yeah, so final conclusion is that this mushroom-based packaging offers a revolutionary approach to sustainable packaging, and also if we combine this such biomaterials like mycelium or seaweed, then it can drastically reduce environmental pollution and it will promote circular economy. Circular economy refers to when the waste, everything is getting repeated, everything is getting naturally regenerated in the economy. Another thing is if we will be developing it with more research, testing and scaling, then definitely these innovations can redefine the packaging standards for a sustainable future. There are some references where we have taken this, and then we will like to thank you and let's move ahead to a better sustainable world. Thank you. Please.
Thank you, Team Greenverse. Over to the judges, to the panel.
What is the final product you will make?
So there will be like cardboard packaging. It will be just like that. And the interesting part that it will be very rigid. So it can even protect the materials like electronic items or fragile items also.
And what is the raw material you are using?
Basically, we will be utilizing the husk that is mostly getting waste like agriculture waste like husk or rice stalks, and we will be integrating it with mycelium, which will bind it very strongly. Yes.
And what was this powder you showed us?
Actually, that's the basic part. Actually, this is one of the intermediate product. We take the rice husk and we try to reduce the carbon content in it. And after that, we will bind it with the mycelium, and then it will get converted to that rigid cardboard.
And then that will be disposable packaging.
Yeah, definitely. It will be disposable into 1 to 2 months. That's the great thing, guys.
What is the moisture absorbing capability of the final material?
So we are using various silica-based components like fluoropolymer, and we are trying to optimize so that they do not absorb moisture less than 1%. So using
We default your basic materials of rice as what are using are basically moisture absorbing. Right?
yeah.
So we will absorb, right?
We will be using some hydrophobic additive.
Yeah, which will have a coating of 0.5 mm over the material.
Yeah, then the final question is what is the parameter square of after coating of the material and accessible
Sorry, can you please repeat?
If you want to do some coating, it's
Yeah.
very fine and thin.
Yeah.
How long the coating will survive? What is possible? Second thing is how cost effective it is if you are including coating as an additional layer.
So we are, as I told, we are using 0.5 mm coating. So it is staying like we didn't have made prototype and tested. So
Just the transportation is a long process.
yeah, agree.
As smooth as if the coating comes out, then whatever the material you are thinking of may get damaged because of the material.
Yes.
Then one last question. what about the antimicrobial thing? Eventually, it's all based on microbial, right? There is a microbial growth. That's a perfect place for all microbes to grow. So, how do you avoid this?
Definitely that's a problem, but right now we are at the development phase and we are trying to first refine this so that we can reduce the carbon from this, and then we have not moved toward that much detail, but we will be looking for such things which can help us for producing from microbials and water also.
Fundamentally, how do you sure that this packaging has any strength of the
Oh, right. Yes.
That should be answered, right? Before moving to
As I told, it will be rigid. So actually, Dell is a company which is currently working on this. So we have made some optimization in that. As I told, we have reduced the carbon. This is making
some
some.
test.
Sorry?
Any test to check.
Actually, it is in work because it is in work. It's working. And as you asked about cost optimization, so we have I have just done rough cost estimates. It's some for 1 meter, 1 cross 1 square. Its cost is approximately something 10,000 cost. For 1 meter square packaging, cost estimates we have estimated like roughly that is something 10,000 around.
There might be some mistake from this calculation. That's not. That might be for a bundle about 1 meter square into 100 because. Definitely. And the other thing.
Think about it.
That IKEA is currently using this packaging, but the problem is that it is not scaled yet and the carbon content is not that much reduced in that.
People
Yeah.
have tried this in so many
Yeah.
Basic question is how could its moisture content, how could it can avoid microbial. If you have answer for those things, it should be clicked in some time.
Yeah.
Any doubts from the audience? Yeah, please go.
I mean, just a curious doubt, thing, sir. For a packaging, when it comes to food, if you're a food packaging typically, this is for expiry is like best before 9 months. So, if this is going to degrade in 2 months, so would that affect the food quality that is wrapped inside?
I want to mention that this material will be not degradable, like you will put it in the almirah and it will get degraded. You will put that inside the land or somewhere the microbes can come, then it will decompose. It will not decompose on its own. You need to place at that environment, like put it in the land that will attack, microbes will attack that and then it will decompose. And I think that basic packaging is also works like that.
Okay, like microbes are everywhere, like dust particles are like everywhere. For any shop you go, say gun shop. So.
But you made, and that's why we have added that. It means there is already this packaging and that decompose when you put that in the soil because you get the right humidity there, you get the right microbes there, which
Got it.
decompose there.
Got it.
Yeah.
Thank you.
I also have a question. I'm Radhika from this IIT School of Entrepreneurship, and the currently available packaging, like which is made from cornstarch, I guess, the 100% biodegradable packaging as they call it, it starts shredding after some time, like maybe within a few months. So, is it going to address that problem?
Can you please repeat what's
The biodegradable bags available commonly after these plastic bans were enforced. So, they start shredding on their own after a few months.
That might be the issue with that, but as we know the project and from our research we know that this is not easily decomposable by just putting it in a rack. It will get decomposed when it will get a right environment. That's why we have used mycelium and such things, because when it is dehydrated, it is very unlikely that it will get any effect from the normal environment. Yeah, that's why we have used this alternative, not yours cornstarch one. Yeah. Thank you. Any other question? Thank you so much.
Thank you, Team Greenverse.